Welcome to 7.2, the law of sines. Example 2, solve triangle ABC if A equals 61.4 degrees, side A equals 35.5 feet, and side B equals 39.2 feet. So again, we are given two sides. And since the given angle is opposite one of the sides, we know that this is going to be an SSA. So we know we're going to have this ambiguous case of 0, 1, or 2 triangles. So let's see what we get in this case. First, let's go ahead and solve for angle B. And the reason why I'm solving for angle B is because I have side A and angle A and side B. So that allows me to solve for angle B. So again, I will write this as sine B over B equals sine A over A. If you prefer to keep the sides up top, that is fine. Just make sure you cross multiply each time. So plugging the numbers in, we get sine of B over 39.2 equals sine of 61.4 over 35.5. Multiplying both sides by 39.2 gives us sine of B equals 39.2 sine of 61.4 all over 35.5. So plugging this right-hand side into the calculator, we get sine of B is approximately 0.96949. In order to find angle B, we have to find sine inverse of that value. I will use the answer function to keep all of the decimals in there, and we get 75.8. So B is approximately 75.8 degrees. This is where we have to check if there is a second triangle for this given information. So let's take this off to the side. So we found that sine of B was 0.96949, so on. And we know that sine can be positive in quadrants 1 and in quadrants 2. This other angle in quadrant 2 might actually give us another triangle with a totally different solution. We already found the reference angle was 75.8. So the reference angle will be 75.8 in quadrant 2 as well. So if there is a B2, and we don't know yet, then it will be 180 minus 75.8. So this second angle might be 104.2 degrees. Now we do not know if this second triangle works yet. We actually have to find out the third angle and see if in fact this triangle exists. So the way we do that is we go ahead and we calculate that third angle, which is just going to be 180 minus A minus B2. So we get 180 minus A, which is 61.4, minus B2, which is 104.2. And because we get a positive answer, because we get an angle right here, this tells us that the second triangle exists. A positive answer for this third angle tells us that a second triangle exists. So now that we've established this, we're not going to just call this B, we're going to call this B1. So we actually have two separate triangles now. So one triangle is going to be acute, and the second triangle will be an obtuse triangle. So I've drawn up our given information. When I go to pull over the other information into this, what's really important is we only take the given information and any of the calculations we made for this triangle, in this case B2 and C2. Given was that my B is 39.2 and my A was 35.5. So to finish this one off here, we still need to find little c. But since there's going to be two different c's, I'm going to call this one C2, and this one I'm going to call C1 for the angle and side C1. So lastly, let's go ahead, since we've almost finished here, we're going to now find little c2, and that will be over sine of c2. And since we were given side A and angle A, I will still use A and sine A. To solve for C2, we either cross multiply and solve or multiply both sides by sine of 14.4. Either way, we would get 10.1, and our units are feet. Coming back to our original triangle, we have to find angle C1 and side C1. So first we'll find angle C1. We will just do 180 minus A and minus B1. So 180 minus 61.4 minus 75.8. And we get C1 to be 42.8 degrees. Now we need to solve for side C1. We will use a similar version of the law of sines, but it'll be C1 over sine C1, but equaling A over sine A. Plugging in C1, we get sine of 42.8 on the bottom, and we still get that 35.5 over sine of 61.4. Solving by cross multiplying or multiplying both sides by sine of 42.8, we get C1 is approximately equal to 27.5 feet. So this is a lot to take in. The main thing to know, the only time you need to worry about having multiple triangles is when it's an SSA. Once you get an angle for that first missing angle, you try and find the corresponding angle in quadrant 2. So you find its supplement. And then if this third angle on this obtuse side, if this third angle exists, meaning it's positive, then you will have a second triangle. That means you have to solve both the original triangle and the new triangle. Another way to do this, I just didn't have enough room to do it while I was solving, is to see that this A, since it's given, that will be in triangle 1 and in triangle 2. The same is true for side A and side B. Those will be consistent for both triangles. However, all of the other information is different. Because we found B to be 75.8 degrees, and its supplement was 104.2 degrees. And because over here, because we found a positive C value, it means this triangle actually exists. So we use that to find the the final side. And then we had to come back here and solve for the original acute triangle for both the side and angle for C. The third angle over here is 42.8 degrees, and the third side was 27.5 feet. So again, the given information applies to both triangles, but the remaining sides and angles will be different for the two different triangles. I hope you enjoyed this video. See you next time.